These are the questions are must watch before going into BITSAT 2025. So this includes the previous year questions also, and as well as most expected questions as well. So without any further delay, let's get started with the first question. A gaseous mixture contains H2 and D2 in 3:1 molar ratio at 300 Kelvin. If the mixture effuses through a pinhole, what would be the molar ratio of H2 and D2 in the first 25% of the gas that effuses out? Okay, so we very well know that R, the rate of effusion, which is inversely proportional to concentration, molar mass actually, molar mass. So how I can write it? RH2 by RD2, which is equal to m root of md2 and root of mh2, right? So for H2, here I'm having 3:1 ratio of H2 and D2. So how I can write it? Rate of effusion, molar ratio is 3:1. So molar ratio, number of moles into our one rate of effusion, that is 1 by molar mass of H2, that is 2, which is 1 by 2, which will give you 3 into 0.707, 2.1 to 1. Similarly, if I am calculating it for D2, then that would become 1 into D2 mass would be 1 by 4. So it will become 2.601. The total effusion is 2.121, 2.601, totally 2.621. Correct? So now they are asking for 25% only. So in case of 25%, H2 is 2.121 out of total, that is 2.621, which is 0.8. Similarly for D2, which is 601 divided by 621, which would be 0.191. So what is the ratio for this? Which is 0.80 divided by 0.191, which will be approximately 4.24 is to 1. Okay, answer to this question is option B. Moving on to the next question. In the electrolysis of molten NaCl using inert electrodes, if 2.3 grams of sodium is deposited at cathode, the volume of Cl2 gas liberated at anode at STP. Okay, so what is the cathode reaction over here? That is Na plus electron gives Na. That is cathode part. What about anode part? Anode part is 2Cl minus gives Cl2 plus 2 electrons. That is anode part, right? So the moles of sodium deposited at cathode we have to calculate. That is given. So that is 2.3. So moles of sodium that we are going to calculate from 2.3 divided by 23, that would be 0.1 mole. Okay, so how many electrons are involved? That is also 1 electron for 1 sodium now, so 0.1 mole of electrons. So from stoichiometry ratio, what we can find it? 2 mole of electron produces 1 mole of Cl2. Correct? 2 mole of electron produces 1 mole of Cl2. So which means 0.1 mole of electron produces 0.05 mole of Cl2. So what is the volume of Cl2? Then that will become volume equal to 0.05 into 22.4. At STP condition they have mentioned, so 22.4, that would be 1.12 liters. Option A. Then solubility of AgCl in 0.1 molar NaCl solution is 1.25 into 10 to the power minus 9 molar. The solubility product of AgCl is, so how I can write the reaction? AgCl gives Ag plus and Cl minus ions. So concentration is 0.1 molar. So in 0.1 molar NaCl, the concentration of Cl is 0.1 okay, plus yes. So yes, the solubility would be very small in case of HeCl. So I'm taking that as approximately 0.1 only, the concentration of Cl minus. So Ag concentration, Ag plus concentration would be, that is yes, which is equal to 1.25 into 10 to the power minus 9. So Ksp value, that is concentration of Ag plus and Cl minus, which would be 1.25 into 10 to the power minus 9. For Cl minus, I'm taking 0.1. So which will be 1.25 into 10 to the power minus 10. So which makes option A as the right answer to this question. Next question is, a buffer solution contains 0.1 molar acetic acid and 0.2 molar sodium acetate. If 0.01 mole of HCl is added to 1 liter of this buffer, what would be the change in pH? Okay, so the Ka value of acetic acid is given, that is 1.8 into 10 to the power minus 5. So first we know the formula. Initial pH would be pH equal to pKa plus log of salt concentration by acid concentration. Correct? So just I'm going to substitute the values. From Ka value I can calculate the pKa, which will comes out to be 4.74 plus log of A minus what is the salt concentration, that is 0.2, and acid concentration is 0.1. Great. So it is giving us the answer 5.04. So after adding 0.01 mole of HCl, how much value? 1 liter buffer. So this is 5.04. After adding HCl, the reaction will happen like CH3COO minus plus HCl will take up, which will give you acetic acid plus Cl minus, right? So the acetic acid concentration would be 0.1, which is already there, and 0.01, which is added from which we got from after adding HCl. Are you getting my point? So the concentration of acetic acid will be the addition of 0.1, which is already there, 0.01 after adding HCl. So total it will become 0.11 molar. Correct? So similarly for COO minus, it will be reduced because after adding HCl, the acetate concentration will get reduced. That's what became our acetic acid. So 0.2 minus 0.01, which is 0.19 molar. So that is the concentration of acetate ion. Okay. So once we know this, the new pH which will be 4 on 4, that is pKa of acetic acid plus log of salt by acid, which is 4.98. They are not asking about the new pH, they are asking difference in pH. So difference in pH, now we have to subtract both. The first value I got, that is 5.04. Now the new pH is 4.98, which will produce, the difference is 0.06. So answer to this question is 0.06, which is not in the option. So you can take the approx 0.05 as your answer. Okay. So moving on to the next question. For the cell reaction of magnesium plus copper 2 plus gives magnesium 2 plus copper. Okay, the standard free energy change is minus 590 kilojoule per mole. The standard EMF of the cell they are asking. Okay. So what is the formula? Here we know delta G naught, which is equal to minus NFE naught. Just substitute the value. This is given in kilojoules. So minus 590 into 1000, which is extra 3 zeros, equal to minus how many electrons are participating? 2 electrons into 96,500 into E naught. So I have to get the E naught. So the answer becomes 3.06. Okay. Moving on to the next question. The degree of hydrolysis of 0.1 molar ammonium chloride solution is. The Kb value and Kw value is given. Okay. So degree of hydrolysis, what is the formula? For weak base and strong acid, right? Ammonium chloride is formation from ammonium hydroxide plus HCl. Weak base with strong acid. So what is the formula? Degree of hydrolysis, H is equal to root of Kw by Kb into C. We already gave you the chart for this degree of hydrolysis and Kw value, everything in the single chart in our previous crash courses, previous one shots. So kindly go through this if you are not aware of that. Let's move on to the calculation. I'm going to substitute the value, that's it. So H is equal to Kw value 10 to the power minus 14 divided by 1.8 into 10 to the power minus 5, that is Kb value, into concentration 0.01, which will become the answer 2.36 into 10 to the power minus 4. Option A. Okay, the next question. The critical temperature of CO2 is 31.1 degrees Celsius and critical pressure is 73.8 atmospheric pressure. The van der Waals constant A for CO2 is. This is from states of matter. It's entirely for the. Now this part is not in the NCERT, but I'm giving you the formula. If you want, you can calculate and know that. So at critical point, at critical temperature, A is equal to 27 R square Pc square divided by 64 Pc. Okay, just you need to substitute the values. So here temperature is 31.1, which will become, substituting here 27 R value, that is 0.0821 R square, and temperature is 31.1, 31.1 plus 273, which will become 304 square divided by 64. Pressure is 73.8. So by solving this, you will get 3.64 as your answer. Okay, moving on to the next question. The freezing point of 0.1 molar aqueous solution of this complex, potassium complex, and the Kf of water is given. Assume complete dissociation. Okay, this is the part where the solution and coordination chemistry combines to produce the answer. The simple thing, just you have to know the factor, how many ions are produced. So for this complex K3FeCN6, that will produce 3 potassium and 1 FeCN6 minus, so total the I factor is 4 here. The van der factor is 4 here. So we know the freezing point formula, delta TF, which is equal to I into Kf into molality. Okay. So what are the values are given? I is 4, Kf value is 1.86, and molar 0.1, which is 0.744 degrees Celsius. So answer to this question is option A. So some questions you will encounter easy one in BITSAT, some questions will be the lengthy one, sometimes that will be a tricky one also. Okay, so don't think like always a toughest one you will get. Okay, moving on to the next question. For the reaction of AB plus B give you the products, the rate law is rate, the equation is given if the concentration of A is doubled and B is tripled. So already we gave you the chart, which is what? So how many times if the concentration happens, what will happen to the rate? So A is doubled and B is tripled. So what will happen? So rate becomes, the new rate becomes doubled A and tripled B. Correct? So which will be 4A square and 3B, which is 12K A square B. So the answer is, it is increased by 12 times. Okay. Then pH of 0.01 molar of HCl solution at 50 degrees Celsius. Hope this you can easily do. So I am skipping this question. The molar conductivity of 0.025 molar methanoic acid is 46.1 and delta naught of formate is given, delta naught of H plus is given, the dissociation constant of methanoic acid is they are asking. Okay. So the molar concentration which we have plus lambda of methanoic acid, right? So the values given are 49.6 plus formate, that is 54.6. So which is 404.2, right? They're asking dissociation constant, which is alpha. So lambda m by lambda m naught. Lambda m, which is given a molar conductivity of methanoic acid is given 46.1. So 46.1 divided by what is the value we found, 404.2, which is 0.114. So dissociation constant, which is, I am writing over here, Ka alpha square C by 1 minus alpha, which is 0.114 square. The concentration is 0.025 divided by 1 minus 0.114, which will comes out to be approximately 3.2 into 10 to the power minus 4. That is option A. Okay. The next question is at equilibrium constant, the reaction is if the 1 mole of each is in the container, number of moles of HI formed. The next question, the number of bridging CO ligands in M2CO10. So bridging CO ligands they are asking about. So how many CO are bridging over here? There is no bridging at all in this complex because it will look like this. So it has the structure with no bridging between Mn and Mn, but each Mn has 5 CO terminal ligands. Okay. So please be careful with this type of question. There is a similar question in the chromium also. Just take care of that. Then organic part. The organic compound with the molecular formula C8H10 shows the following properties. Gives positive test with bromine with CCl4 on ozenolysis followed by the reductive workup, gives benzaldehyde and acetaldehyde. Okay. benzaldehyde and acetaldehyde, fine. And then it shows stereoisomerism. The compound is, okay, they have mentioned it shows geometric isomerism. Fine. So the first compound, that is phenylethene, which will look like this. Correct? On osmolysis, that will give you not acetic acid, it will give you formic acid, because osmolysis means break the double bond, put double bond O, double bond O. It will give you formic acid, not acetic acid, acetaldehyde. Okay. The second one, 1-phenyl 1-propene. 1-phenyl 1-propene, 1-phenyl propene, which is the compound like this. So upon doing the osmolysis, it will give you acetic acid and acetaldehyde and benzaldehyde. Okay, this can be considerable and gives positive test with bromine water, that is having double bond. Okay, then shows geometrical isomerism. Geometric isomerism, you could see one side H, another side CH3, one side H, another side phenyl. So it can also show geometric isomerism because of different groups attached. And option C, what it says, okay, 2-phenyl propene, 2-phenyl 1-propene, 2-phenyl 1-propene. So this will give you formic acid, not formic aldehyde, not acetaldehyde. So this can't be our answer. And ethyl benzene, so which is not at all giving the positive to any test, and geometrical isomerism not possible. Osmolysis is not also possible. So our answer to this question is option B. This question asking about which of the following will give highest yield of the desired product. Benzene with CH3COCl, acetophenone, and ethyl COCl, that is propiophenone, and tertiary carbon with this, which is giving tertiary butylphenone. So one thing we have to consider here is these all are following Friedel-Crafts, right? Friedel-Crafts acylation. So steric hindrance increases in the order of options. C will experience more steric hindrance, and then comes B, and then comes A, right? So Friedel-Crafts acylation efficiency will decrease in case of increase in bulk groups, correct? So which makes option A as your right answer. Very simple question, but you have to understand what they are asking. The major product formed when 2-methyl but-2-ene reacts with HBr in the presence of peroxides. 2-methyl but-2-ene, but-2-ene reacts with HBr peroxide. HBr peroxide is a very successful combo for anti-Markovnikov addition, right? So H plus and Br minus. Br minus will go to more H plus site, which is less substituted site. So which will produce the product like this. H will occupy here, Br will occupy this position. So which is 1, 2, 3, 4, and second position I'm having Br. So 2 bromo, 3-methyl butane would be your right. So answer to this question is option D, 2 bromo 3-methyl butane. Which of the following statements are correct for lanthanides? Okay, the atomic gradient decreases regularly from lanthanum to lutetium. They show variable oxidation state predominantly +3. Their compounds are generally colored due to FF transitions, and all lanthanides form stable complex with EDTA. Okay, so let's analyze one by one. Lanthanide contraction happens, right? Due to that, what will happen? The decrease in atomic radii. So statement A is right and statement B is also right. +3 oxidation state is the most common oxidation state in lanthanides. And statement 3, their compounds are generally colored due to FF transition. That is also right. And all lanthanides form stable complexes with EDTA. Not all lanthanide form, but lanthanide forms as EDTA can able to form a stable compound with any metal. So not all lanthanides form the equally stable complexes. So which makes 1, 2, 3 only right. And product formed when benzaldehyde reacts with concentrated NaOH. What is this name of this reaction? Can anyone tell me what is the name of this reaction? Benzaldehyde with concentrated NaOH. Let me tell you the product also. Just tell me in the comment what is the name of this reaction. The product is benzyl alcohol and sodium benzoate. It is undergoing disproportionation reaction, and this is very important reaction. The conditions can also be asked and the products can also be asked. Then the next question for the reaction of this, delta HF naught values are given and the reaction carried out 500 Kelvin and delta Cp is given. Okay, delta H at 500 Kelvin they are asking. I think this reaction happens at room temperature 25 degrees Celsius. So I'm assuming to take 298 as the temperature happened. So delta H naught 298, which is equal to minus 235.1. I'm just subtracting the values. I'm substituting the corresponding value 241.8 plus remaining 52.3, which is minus 45.6. They are asking for delta H at 500 degrees Celsius. So 500 degrees Celsius, which is equal to delta H naught at 298 plus delta Cp, which is T2 minus T1. We have to put. So the found out value 45.6 plus delta Cp is given as minus 123. Minus 123. And the temperature difference 500 minus 298. Just you have to put, which is 202, which will become minus 46.4 as your answer. The radioactive sample has 16% of its original activity after 3 halves life. The percentage error in this measurement is, they are asking about percentage error. Okay, so after 3 half lives, what is the activity should be? The 16% of its original activity. After 3 half-lives, from 100% to 50%, that is 1 half-life, 50% to 25%, that is 2 half-life, 25 to 12.5, that is 3 half-life. Ideally it should be 12.5, but here I am having 16. So the error, the percentage error equal to 16 minus 12.5 divided by 12.5, which is equal to 20.28. The percentage error would be 28.6. Which of the following ethers can be prepared from Williamson ether synthesis? So Williamson ether synthesis is undergoing what type of substitution? That speaks a lot. Okay, so where we are involving, we're including RONA. So RO minus is acting as a nucleophile over there. So depend on that, we have to do the calculation. So to produce, the first option says di-tertiary butyl ether, tertiary butyl phenyl ether, diphenyl ether, and all of the above, which can be prepared from Williamson ether synthesis. Tertiary butyl phenyl ether, in option B, use how we can prepare that? PHO minus plus tertiary butyl bromide. So in this combination only we can prepare, which follows SN one reaction mechanism. In case of ditertiary butyl ether, which is not possible, the groups become more and more bulky, and diphenyl ether also not possible because that will have a structure like this that will not undergo SN1 or SN2. So answer to this question is option B. Then, which of the following method gives better yield of para-nitrophenol? Okay, so the first method, which is a simple nitration, right, electrophilic substitution reaction. The second method, which involves two-step, phenol first reacted with our number one reagent, okay, this reagent, and that will form nitrosophenol. The para position will be occupied by NO group and followed by the second reagent NHNO3 that will give you no other option, that will do the para position only. But in case of first method, ortho and para substituted products can be the option. So phenol OH group is there, so ortho para group can be your product. And option C is not at all in the combination, that will not form any product. Okay, so A and B, comparing A and B, B will give you the better yield than A because para-nitrophenol via the formation of para-nitrosophenol, which avoids the oxidation of OH group, hydroxyl group. So that makes B as your right answer. Moving on to the next question. Formation of calcium carbide takes place as follows. Given reaction sequence, okay, the amount of polyethylene obtained from 64.1 kilogram of calcium carbide. Okay, so this is the reaction happens over here. We have to calculate the amount of polyethylene formed. So which is polyethylene over here? This is polyethylene. So how much it is obtained? Let's see. First of all, calcium carbide is forming H2, C2H2, ethene, and then ethine forms ethene forms polyethylene. That is the process. So all are in 1:1 ratio, correct? So first let's calculate the molar mass of calcium carbide. Calcium carbide, which is calcium 40, carbon 2 carbons, so 12 into 2 24, 40 plus 24 64 gram per mole. So 64.1 kilogram of calcium carbide is taken. So which means moles is 64.1 into 10 to the power 3 divided by 64. So which makes 1000 moles, right? So 1000 mole. So 1 molar, I already told you 1:1 ratio is followed over here. 1 calcium carbide, 1 ethine, 1 ethine produces 1 ethene, 1 n number of ethene gives polyethylene. So whatever the ethene is they are having, that will give you the polyethylene. So let's calculate 1000 moles. Polyethylene, what is the molar mass? 2 carbons. Ethene. So ethene, the mass, molar mass becomes 2 carbon, 4 hydrogen, 24 plus 4, 28. So mass, which is equal to mole into 28, which is 100 into 28, 20,000 into 28, 28,000, which is nothing but 28 kilograms. Right, 28 kilogram is the option answer to this question. Sometimes the color observed in Lesine's test for nitrogen is green. It is because of. The green color of ferrous sulfate, ferric ferrocyanide is also green. The green color of copper sulfate, and excess of Fe3 plus ions whose yellow color makes the blue color of ferric ferrocyanide to appear again. Okay, see in Lesain's test, Cn minus ions react with Fe2 plus, right, to form Fe2 FeCN 6 times. Correct, this is the product form which is Prussian blue. So that when excess of Fe3 ions are there, the yellow color of Fe3 ions mixes with this blue color to give green as its appearance. So option C, D as your right answer. Fructose on reduction gives a mixture of two alcohols which are related as. So fructose on reduction gives D-sorbitol and D-mannitol, right? So which are both are diastereomers and epimers. Why is it so? Because that one differs in the C2 carbon. So which differs in C2 carbon only, that is epimer. So epimers and diastereomers, which makes option C as your right answer. What will happen when T plus glucose is treated with methanolic HCl followed by Tollens reagent? Okay, T plus glucose is treated with methanolic HCl. So what are the options given? Black precipitate, red precipitate, green color, no characteristic color. Okay, methanolic HCl, what that will do? It converts glucose to methyl glucoside, okay, which is also known as acetyl. That will protect the anomeric carbon of glucose structure. It will result the acetyl. It doesn't have any free aldehyde group, so it will not give positive to Tollens reagent. So no characteristic color or precipitate will be formed because there is no CH3 group is there. Which of the following forms a base of talcum powder? This is a factual question. The answer is magnesium hydrosilicate. The formula is Mg3Si4O10OH twice. The first emission line in the atomic spectrum of hydrogen in the Balmer series appears at. Okay, so Balmer series means what is the jump happens over here from two state, Lyman, Balmer, right? Second one. So 1 by lambda, which is equal to RH 1 by 2 square minus 1 by n square. So first emission line, which I am taking that as 3 to 2. Okay, so n is equal to 3 and n is equal to 2 state that is happening, n1 and n2. So I am substituting the values are 1 by 4 minus 1 by 9 plus n, I took that as 3, first emission line, that's why. So what would be the values? 9 minus 4 or 9 minus 4, 9 4 36, so 5 by 36, right? So 1 by lambda, that is 5R by 36. The hypothetical complex fluorodiaqua triamine cobalt 3-chloride can be represented as. Okay, cobalt chloride. Okay, so name indicates that there should be 2 aqua, diaqua, triamine. Triamine, all are having 3 amine group. Okay, diaqua, so A or C, cobalt 3-chloride. So which makes option A as your right answer. Which of the following compound has all 4 types of carbon atoms, primary, secondary and tertiary? So neopentane, which will look like this, 1, 2, 3, 4, 5, right? And 2, 2, 4, trimethyl pentane, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 2, 4, trimethyl pentane, and once again trimethyl pentane, which 2, 3 and 4. Let's check. So the first one, that is having quaternary and primary only, so which is not our answer. The second one, CH3 groups are our primary, and apart from that I'm having these 3 groups. So this is secondary, this is tertiary, and this is quaternary. If I'm taking C, these are similar groups, so I'm not going, that can't be our right answer. Only the answer can be option B. In this question they are asking to find out the product. So here we are having the very simple product, phenol and acetone. So phenol and acetone, first of all what will happen? Phenol in the presence of acid medium. Okay. So it will form a structure like this. This part will be taken over. So that will give you double bond OH. And then remaining I'm having CH3 with COH. After that it will again attacked by OH and undergoes the rearrangement to produce OHCCH3 with phenol, but it will not stop over here. Again it will undergo the reaction with H plus to form another mole of, taking up the another mole of phenol to produce bisphenol kind of structure. So for each double bond it will take up one phenyl ring, so which will produce a structure of OH, option D. So finally it will produce the structure of option D. Okay, this is bisphenol A. So hope these questions are helpful. We have solved some medium to difficult level of questions. Let me know if you need only the difficult questions. We'll do it that. Okay, all the best for your exams. Let me know what else you want, which concept need to be discussed, or which type of questions you want.